today we're going to draw the airplane, paper airplane, and we're going to do two drawings. The it's a little light here, but orthographic views of it, and also an isometric view. And we're going to use tools, okay? We're going to go a little bit back and forth between using tools and using freehand drawing. And in fact, for Wednesday, just to let you know, the text on the handout is slightly different than the one on iLearn, because I want to keep the object that we're going to draw next a little simpler, or rather more open. We can have simple objects like hammer, scissors, etc. Okay, but I'll go over that on Wednesday. So for the orthographic, we want to do the three views, right, of your paper airplane, and I'm just going to highlight them a little better here. Like that. And I didn't double check absolutely if it's going to fit exactly like this, but I think it will. What we'll do is we'll draw light lines to determine where the object is inscribed, and then we'll do darker, more precise lines for the actual object. Okay. So let's look at these airplanes. I have a big one, and I made myself a little one because otherwise I can't really show you very well. Okay, so I'll be going back and forth because I want to measure these things exactly. So the first thing you need to do is to pretty much roughly figure out where on your paper, on your 8.5 by 11, you're going to put these things, right? So let's just say if that's the top, I'm going to do it very schematic now. And this is the side, and this is the other side. Okay, so you need to know how big this is, how big that is, and how big that is. Right? Pretty much width, height, and depth. And there's several ways to do that. One is to measure, right? And I brought my really fancy, nice rulers today. So simply you just measure it, right? And you see how big it is. So mine is about, this is a half scale, I think, so it's 2 3/4. And this is 7.5. Some of the difficulties are the fact that this point is a little bit inwards. So if I were to be really correct, I would have to draw a line here, right? Because it's going to be all the way out to this point. But you need to determine that that's the outermost point, and since you can't measure it from there to there, you're going to have to measure it this way, coming out, you know, put an object, something like that, so that you know, okay, that's where it is. The same thing happens with the side of your airplane. Let's see if I find a better drawing. This is pretty good. So once we have our airplane, you could do it two ways. You could do it pitching down like that, right, with this being the horizontal, or you could have it flat like this, with this being going up. And that's really the way we want to draw it, right, because we want to imagine that it's maybe flying or something. So rather than being this line, your base, you want to turn that so that becomes whatever, and this is your true dimension. So that the height, if you look at the model, it looks roughly square, but it really isn't once you, if it was like that, then that would be straight, right? But because we're tilting it like this line is actually at an angle. So what that means is that the height cannot be measured on this line, but it has to be measured here at a 90-degree angle. So one way could be to take this object and draw a line that's straight. Now, how do I do that? Well, I could kind of cheat, or at least do a shortcut. Put my triangle there, move it across, and that's my height, right? Okay, so once we have determined that, we have, let's see, the other dimension that we need is going to be from this point to this point. Now that you can pretty much measure, right? If your object is pretty regular. Okay, so this is 2 3/4. So it probably means that my original, let me see if I did this right. 2 3/4, yeah, it's not quite. I'm going to get confused now between the two, but start with your original. So if your original is, in this case, 4 1/2, the half would be say 4 1/2. Yeah, 2 1/4. Okay. This is going to be 11 1/2. So that's 5 3/4. I think I've actually written this down in iron. And then my height is let's just say 2 inches. So it's 1 inch. So these are all at half scale, right? So that's the way we're going to draw it. Now, if your design is different, of course, you're going to be doing your design, right? You don't have to have this particular design. But that's pretty much it for the orthographic, in the sense that all you have to do is really align them in the drawing. That's why you use your projection lines. Notice that this point right there is going to be, of course, my vertical for my height. And just simplify the drawing, okay? Don't try to show, all the folds and everything. If you want, you could show a slight double line there, just next to each other, like that. And that's it. And then in the title block, you should say scale. 1 inch, ½ inch equals 1 inch, right? Because it's half scale. Okay, I'm just going to quickly show how to use the rulers again. And I'm just going to draw one thing. I brought my, again, fancy rulers just to show you that you can, there's no end to how precise you can try to be. These are Mylar. They're really great because you can measure around things, and they're very strong. And in this particular case, it has inches and millimeters, and it's got 64ths of an inch. So my pencil here is actually pretty good because I think I can get down to that. So if I make a line with this pencil, where are we? I'm actually doing quite well because the line is about as thick as the marking on the ruler. So, that space between the first and the second mark is 1/64th of an inch. So, I don't know what that is. Probably, 1/300th of an inch, 1/600th. So that's pretty good. And then you also have millimeters, And these rulers are beautiful because they're really, really sharp. The markings are really not competing with the space that in between them that the marks are trying to measure, right? One nice feature of one of these rulers also is that it has decimal inches, so that you know how in the computer you're always wondering whatever is 3/8, right? Well, this will give you really nice decimals for the inches. Okay. So let's assume I know now where I'm going to put my first box. Okay. And let's just say it's there. Okay. Always use either a T-square or two triangles like this. You just move them up and down, and I'm just going to say now that's my horizontal. So I start always with a kind of with a reference point line, and on that I build up my sketch. So I said it was 5 3/4. Okay, 5 3/4 by 2 1/4. So 2 1/4, 1 1/8 on each side. Okay, so with that I start building up my box. So again, put one ruler down, one triangle down, hold it with your hand, slide the other one. Can't see it from here, so I'm going to use this edge. And then when it meets the markings that you made right here, now I have a problem there, right? Because I can't quite get this edge to give me a line there. But because I've started here, I can flip now my triangles and go from that line. Right? That. Okay. You can kind of see those lines. Anyway, I'm going to do them a little darker for you to see, although you want to keep them light in the construction. You can leave them in the drawing, okay? Try to use the eraser really as little as possible. So now that we have that, we need to figure out where these are, and really I just need to measure one, and I can, roughly say, okay, that's 5/8, now 3/4 from the edge, and this is about 1/4. So I'm going to half it, 3/8 and 1/8. And now I'm going to use this line here to see how far I am from that inlet there for the tail. That's 3/8, so that would be 3/16. And I've got all the information that I need. Just going to draw it now. I'm doing a terrible job because it's hard to look at it from the side rather than from the top. Okay. Okay, now I don't need to measure on the second side because all I have to do is bring those lines over, right? I really just need one line. Which is that point right there. So I bring it over. Actually I take it back, I do need that point. So I'm gonna just measure that again. We said it was 1/8. I'm not going to draw the other views, but now with this information you have enough to start building the other sides as well. Okay, that is, now you would project these lines down. You would start with your other thing here, you would measure your height, and you get the very basic side view, and then the other side view. Okay, so for the isometric one, I'm just going to use existing drawings and go over them as needed. We're going to use the 30-degree triangle. So this guy here for both sides. Okay, so make sure you do that, because that way we can all compare notes and we're all on the same page. And you could have different angles. You could have 30-60. So for example, you could have 60 there, and yeah, and 30 here. And so this would be a case in which you have the square, your airplane, you simply turned it up, and then you just extrude it up like that. But we don't want to do that, okay? We want to be able to squish this thing. So you practice already a little bit with axonometric and isometric. The first thing to do again is to build the outside box of this object. In other words, imagine there's like a glass case that's enclosing it, and all the faces are touching this point, this plane, touching that back, and touching this here. Okay, so that would be your original box. And the dimensions, because we're using 30-30, don't change, meaning they stay proportional. So it's also at half scale, right? So in your drawing, it would be roughly about, again, what is it? It's 5 3/4. Let's see. Yeah, it's a little bit bigger than this. So just center it on your page. This sketch, again, just shows how one dimension, or rather one diagonal, if it was a cube, is the one that gets squished, and the other ones get, expanded. But the verticals and these two dimensions don't change at all, okay? So these you would have real dimension, real dimensions, real dimensions. The way you get your measurements to move across from one side to the other is simply by projecting parallel lines. So you would plot these points on your perimeter, okay? Right here, you would plot this spot right there, and then this. The shape here is a little funny, but and then you could just bring those back onto this oblique view. Now, you can also just do it once over here, and then bring it across like this to find the other one. Here you have to measure. You have no choice, right? So you have to measure both from there to there. And the other tricky part in this one is that where to find this spot for the I don't know what you call this, the rudder of the tail. So these things right here. So that's a vertical line. So the vertical line extends from this part right here, right? Not from there. And it's likely that maybe you won't see it at all, depending on how big your airplane is. Meaning that once I extend that down, In this case, it's a very deep, it's a very high airplane, right? So it looks like I probably would be able to see some of it. Oh, I'm sorry, I did this wrong. Sorry. So this point right here actually doesn't go down vertically, remember? It goes down at an angle. So you need to transport this other spot, whatever that is. Just measure it a quarter. So right here, oops, wrong one. So right here, I still need to find where that spot is. So I would move it over, and maybe that's my quarter inch, and then I bring it down. Okay. And where it meets essentially the parallel line to my top, down at the bottom of my hypothetical square box, I mean a glass box. So I drop it down vertically, that's my line. So now I can connect this and this, and I get my true airplane. And now I can highlight this. So once again, you can keep this drawing with light construction lines and darker for the actual object lines. Okay. And once again, you might not be able to see that at all. It will just depend on your drawing. If you want, you can do 2 lines here, like that, to give an indication of the folds. So once you do your orthographic drawing, you should have all the information that you need to make this one. This just shows it going the other way. So I don't know, I mean that could be an option, I guess. I didn't think about that before, but you could theoretically orient it like this, in which case you very likely you would see a little bit of your tail here. But it's up to you. That's more conventional, right? And again, isometric is really just one variation of axonometric, various axonometric. And it just means that they're all the same, the 3 directions. The ratio of reduction, it's called. It doesn't vary. Whereas if your angles were like this, so that's essentially 0, this is 45, you would vary this angle, you would shorten that angle by 1/2 to make it look right, if it was a cube. Just a reminder, once again, we're just doing isometric or axonometric, so we're not making lines converging at all, either to the front or to the back. Just more drawing showing again how to find that spot, touching. You could call that the landing gear of your plane. So more or less center it, in the space of your page. That's a messy drawing. Okay. Yeah, if your design is different, I guess you'll have to see what you have and take those measurements. One quick way to take these dimensions and half them is, again, to take a piece of paper and just mark it and then fold it, right? Again, if you didn't have anything, if you didn't have a ruler, if you didn't have, how do I find that half? I just fold it. Okay, that would be my half. Okay, so for this drawing, once again, we'll use precision instruments. We use triangles. We use either a very sharp pencil or a mechanical pencil, And let's try not to use a razor. Let's try to make the lines not too thick, but rather make them darker, so that, yeah, you can't really see that. Let's see that versus that. Okay, so these are pretty much the same thickness, but this one is sharper, darker, crisper, whatever. Okay, and the construction document, the construction drawing can look very organic, like your lines can extend, can cross and so forth. Okay, stop there.